Okay, next up we have Nathan Peters of 2017. Nathan joined Emseal Joint Systems team to cover Western North America as a territory sales manager.
And yeah, as he said, I'm Nathan Peters. I'm with Emseal Joint Systems. I'm the Western Regional Manager for Bridge and Highway projects. So, our company, Emseal, really has a more traditional, rich history in the architectural markets. It was probably about 10 years ago that someone who maybe many of you guys might have known, met, and remember, Irene Friedman, she kind of brought this technology from the architectural world into the bridge and highway markets. So that's kind of where we got our start. We were just kind of carrying on that good fight that Irene had been fighting for so long. We're here, and we appreciate the opportunity to come and share with you guys all. BJS as a technology, I think that what I'd like to try and convey first is, this might not be a new technology, but it may be new to you. So I think that's kind of one of the opportunities that we were asked to kind of come and share about this. So what we're going to try and cover is, this product, how it can be used in bridge preservation as that low-cost retrofit solution. So to get into it first is, what is BEJS? It is a foam-supported silicone. I'd like to call it a composite joint. So essentially what you've got is you've got a open cell foam, which is your base material there on the bottom. It's 100% acrylic impregnated and infused with acrylic microspheres that increase the resiliency and longevity of the product. In short terms, it's memory foam. What we're doing next then is we're actually coating it with a factory applied and cured traffic grade UV resistant silicone coating. So you can kind of see that, that's where that composite joint comes from. You're that hybrid of memory foam and traffic grade silicone. Essentially, I would define it as a silicone foam composite joint. The product is designed to have about 120% movement, so you got about plus or minus 60% movement range, so quite a big range of gaps that it can fill. Product has been designed for, and what so much of the success from the architectural market came from, is that it is one of those few joints that you can say it's watertight by design. So why it works, the main thing, if you were to kind of compare it to the existing technologies that might be out there, it might remind you a little bit of like a foam backer rod with a poured sealant on top of it. So what we're really trying to do is get that resilient backer, the foam, the memory foam below it, and then that factory cured silicone on top. So we're creating that tensionless bellow so that the joint itself is actually never going to see any tension if designed right. We're installing that, and it's applied with multiple points of adhesion, so you can kind of see that with the red lines there on that photograph, where you're actually installing it with an epoxy on the header and coming back through and sealing that with a non-sag Sika 728 silicone to actually kind of seal that edge and create that watertight between the interface of the header. That foam is creating about 2.5 psi back pressure once it's installed within that joint, so that's how it's staying out of tension, always in compression and filling that joint gap. It can be staged in multiple units, and it cures as one monolithic joint seal. So that layer of silicone on the top is what's creating that watertight layer. As you're installing it, it's going to cure as one continuous layer. Fully customizable as far as the foam density, the depths, the thicknesses. We can do the prefabricated transitions in the factory. So really it's one of those systems where you can come to us with a lot of unique ideas, a lot of unique designs, and we can make a product or adapt our product to fit your guys' needs. So some of the systems where we can be used at, we can be used in metal, concrete, elastomeric concrete, PPC nosing joints, any type of epoxy nosing. So really there's no existing header or new header material that's out there that wouldn't work with our product. You can kind of see here from some of the photographs. Far left would be it would be a look at what the metal angle. You've got a photograph there with the elastomeric header. And then what we'd like to highlight there at the far right would be the spalled or irregular concrete, something that our foam joints handle very, very well. Kind of looking at from the concrete. So what we're looking for is that CSP2 profile. Really, the way that we describe it is, the rougher the surface, really the better. It gives a little bit more for that foam to grow into, almost creates that mechanical connection between the header and the foam joint itself. So a little bit of texture is almost better, but that CSP2 concrete profile would be kind of our minimum recommendation for that. Can be achieved through a grinding or demo saw, diamond tip blade, even some sandblasting, just to give a little bit of texture to that surface. And that would be for any concrete. Looking at the steel angle, you're talking about if it's an existing structure, then you want to sandblast it, get that metal down to near white when you're installing it. As I tell people, your installation of that surface joint is only going to be as good as the guts below it. So if you're trying to install that over, a rusted metal or something like that, your adhesive, your epoxies, it's going to have a struggle to actually bond and stay in place over that rusted surface. So a little bit of sandblasting is really all it takes to get that retrofit bridge up to scratch to be able to install the BEJS. We've got a little detail here on this drawing as well that kind of shows the elastomeric nosing that's been, essentially a small saw cut next to that angle. Joints are a pretty problematic thing, and the seals are a big part of that conversation. I think that conversation as a whole really goes beyond that, though, into those header materials, where your mode of failure is, even before it even gets to the joint seal. I think that's a good recommendation or a good design note to keep in mind, especially on some of those retrofits, to where if you can seal any of those lines where water can penetrate, go around, if your seal there in the center is watertight, but you've got water actually penetrating in and around that angle, you're going to still have problems down the road. Next would just be a quick detail from with our ORM Crete, which is our elastomeric product. A pretty standard detail and design there. It doesn't have to necessarily be that specific product, but the elastomerics are pretty popular in the header arena, so something that can certainly work with our product. This would be a look at one of our transitions. We call the U90 factory fabricated transitions. Essentially creates that change in plane from the vertical deck up through the parapet wall, maybe a sidewalk. Any of those vertical changes of plane, you're getting a factory fabricated, warranted transition that corner, that edge part is going to be watertight. You won't have any leaks coming through that section. Which is a very problematic portion of most joint systems. So it's an efficient watertight solution for changes in planes, and those standard 90s, they come coated on both sides, so it's a universal. You can install it on an inside or an outside corner. Gives those guys in the field a little bit more flexibility. So that's kind of an introduction of BEJS as a technology. Like I said, not something necessarily new, but maybe a little bit new to you. If we take a quick step back, just kind of look at some of the typical problems with expansion joints, and Becky did a great job of going through a lot of those details and some of those technologies, so I won't dwell on it too long, but I think that not being watertight, that's got to be one of the main concerns. If you've got debris, if you've got water full of chlorides or other types of de-icing chemicals and salts actually penetrating down below that joint, attacking the beams, attacking the bearings, even some of the pile caps, definitely a very problematic place for that. And your joint, you've installed it to protect those parts. If it's not actually maintaining that watertight seal, all you've really done is stuffed a debris trap down there. So they're very hypersensitive to proper installation, something that most joints aren't free from. It's, if you've got to do it right, and the guy's got to know what they're working with, what materials they have in their hands for them to be successful. And there's so many, as Becky pointed out, there's so many different products, so many different types of joints that are on the market. It's pretty difficult to try and keep up and be versed and be an expert in all of those. So you got to really pay attention to those instructions ahead of time. It's very difficult to stage joints, especially high ADT bridges. You're talking about, very difficult to get a one continuous gland from curb to curb without a lot of difficult staging, something that might even be dangerous for crews to be out there working with. Joint materials suffer from compression set failure. So, you've got a joint, it's sized for this specific gap opening, but over time it loses some of that resiliency. It actually loses a little bit of that ability to fill and expand and contract with those cycles. They are unable to adapt to irregular substrates, so some of those spalls. One of my favorite, phrases to say is, in engineering school, I was taught how to draw straight lines. In the real world, I quickly realized that straight lines do not exist. And that is not any more relevant than to the joint market, where you're really talking about you get something drawn on a piece of paper, but you get out there and you find that it is very, very different. They are unable to seamlessly adapt to changes in plane. So as we looked at those U90s earlier, that change in plane from the deck up the curb, whether it be the parapet, the sidewalk, it's very difficult to get those changes in plane seamlessly without having leak points or places where things can actually attack that joint seal. They're difficult to install. Like I said, they are very sensitive to that proper installation, so sometimes you just gotta focus and make sure that you can get that actual product, whether or not it is generally the right product for that type of installation, whether you can get it in or not. Difficult to repair and maintain. So once you get it out there, is that joint something that's, are you sending crews out there to clean it? Are you sending crews out there to maintain that seal so that maybe, you've got a nice looking joint for 30 out of your 35 feet of bridge deck, but that 5-foot section that's become damaged, can you go out there and actually effectively repair that without having to close the whole structure or replace that full 35-foot section? So that's kind of an issue. So here's a quick look. This would be kind of like a poured sealant. This would be one of the most common issues that people have with it. That adhesive failure. So that the range of motion that for those smaller joints, this is a great product. But once you start expecting it to get those wider ranges of motion, you're probably more likely to see those adhesive or cohesive failures in the joint. Is a look at that compression set failure. You're essentially looking at that rubberized joint that can no longer fill up and expand to that full dimension that it was on day one. So you're seeing it actually pull away and delaminate there from the header. A strip seal, which is a very, very common for new construction products or new construction bridges. Once installed properly, if done correctly, it's a great product. Definitely one of the most difficult joints to maintain and repair and actually get something like this to be fixed. You'd have to, you're talking about knocking out feet of concrete back and down to pull out all the anchoring of that. You can't just go in and replace that singular gland at that location based on the failure. Some of the other products, it's difficult, hard to find a bond line. You're going to have some issues of stuff popping out or not actually filling in that gap properly. So, moving on to back to some of the BEJS, some of the reasons why, we are able to perform in those areas, where we can outperform that stuff. So, like I said, it's the memory foam, so you're never going to suffer from that compression set failure. That memory foam is always going to be pushing out at 2.5 psi back pressure as long as you've installed it properly, it's been sized properly, most importantly, but you're still given a wider range of where that size can actually fall in and fill those gaps. That uniform solid foam backing construction, so you've got that one singular piece of foam there. It's coated with the UV resistant waterproofing material, so that's where that true watertight seal is coming from on the top side, not necessarily the foam below, but that silicone cover is your most important part when installing that to make sure that you're getting a truly watertight joint. And then it's adhered to the substrate with multiple adhesion points, whether it be the silicone, epoxies that we're mixing in the field and going there. So giving it a beefy header substrate to bond to, grip to, and actually stay in place. So high range of movement, 5-inch max would kind of be our sweet spot. You're up to the 120% total movement. So that medium range joint that Becky was referencing earlier, we're not really pursuing, you're not going to ever replace a finger plate or any of the larger modular joints with this type of technology, but those smaller movement joints is the sweet spot that we've been able to go in and replace with great effect. So it can conform to the irregular substrates with the factory fabricated transitions as well at the curbs, for stage construction. That's a pretty common thing for bridge rehab, is that you're going to go out there, you're going to be dealing with lane closures, you're going to be dealing with having to try and stretch this singular continuous gland across the bridge. The BEJS really solves that problem by letting you install in those 6.5-foot sections. You can seal that off. By the time you can switch traffic, you can continue to install the rest of that joint over, from curb to curb. It's not like you need to shut your bridge down for hours and hours to get something like this installed. Most importantly, I think, from our perspective, from the preservation, maintenance, and repair side of things, it is easily repairable. You can go in and replace a singular section of that joint seal without having to rip out from curb to curb like you would with some of the continuous gland seals. So you can kind of see a joint here on this photo of where those two joints have actually come together. You're bonding them together with a silicone bead. At the time when you're pushing those, what you want to try and do is create a back pressure between those two foam pieces as they're being lowered into place, and then that silicone bead that you're applying at the time will then create that continuous seal from curb to curb. Once again, ideal for staging is really that section where that feature is huge for guys out in the field, especially in retrofit and rehab. You can kind of see from this photograph where that spalling, that irregular concrete, where that foam has been able to grow into that area. You're not leaving any gap, you're not leaving any border there between the interface of the header and the joint material itself, where debris can get in, start creating problems, even water that can start leaking from day one. Back to sealing some of those curbs. that it's very difficult to find some of those materials that can actually go up and around the parapet wall, create that seal that will go and even get some of those far out, those limit, the beams and the bearings that are on the very outer limits of that width of the structure. So you can take that product very easily up and over to seal that full parapet wall. Which is a great feature, to be able to have that ability and to be able to do that, to take that material that you're installing on the deck side and run it continuously up and over throughout that full, that full and continuous seal. This would be, another look at one of those smaller joints, which would be what we would call the BEJS on a reel, kind of looking at coming up and over the parapet wall there. Just kind of a quick look at that. So that would be, a product that's more geared for those smaller gaps, between a 1/2 inch up to about inch and a quarter. It's the most economical for the smaller joint size. Still, once again, 100% watertight and 120% total movement in that nominal size. We've had some of the most success with that specific product, the BOR, is we've actually been used as the secondary seal below a lot of asphaltic plug joints. The curbs become the critical leak point on those systems. So, where they're actually trying to change in plane from where that actual asphaltic plug is being poured to that change in plane, is where a lot of that water debris is settling and dripping through. So if we can get that watertight seal even below that, then they're able to maintain and handle that a lot better. It's, Massachusetts DOT was one of the first DOTs that really started piloting and pioneering this specific design. And just this past year, they updated their specifications book to be, exclusively BEJS is what's being used underneath all of their asphaltic plugs that are being installed in the state. That factory fabricated transition, I've mentioned a couple of times, but that's really the meat and potato product made this joint so attractive to those guys at MassDOT, was that critical leak point right there at that turn, at that upturn. So this would be a photograph of what that installation would look like below the joint. Before that actual asphaltic plug has been poured over there. Just a couple looks at in the middle there. With not that most of the strip seal rails are 3D printed in yellow, but that would be a representation of what that steel header angle, that iron would look like. So a great retrofit option for those existing structures that have strip seals from new construction. Whether or not you can't replace the gland or it's just not available anymore, you can go in and quickly, easily, and cost-effectively repair something like that without having to rip out all that rebar, without having to go in or trying to find a replacement gland that would actually, maybe fit into something that was installed 20 to 25 years ago. Here's a look at some of the fully customizable factory fabricated transitions that we can make. As you can kind of see, this custom piece that's there highlighted in the dimensions outlook there. You can get these types of seamless transitions at those most difficult spots of the joint. Those types of parts usually cost a little bit more on the front end, but the time, the money that the crews in the field can save by popping in that one singular piece versus trying to go out there, measure, doing a little bit of the carpentry work that would go into cutting and mitering those types of parts together. Like I said, something like that speeds up the process of installation and ultimately guarantees that watertight connection at all those transitions. Some of the irregular joint conditions, as we all know, there's not a lot of nice, clean, pretty joints out there that we're working with. We're looking at down and dirty stuff, stuff that always isn't in the most cooperative way once you get out there and you find how it works. But we do handle all of those unique situations very well, whether it be skews, joint tapers, jogs, longitudinal joints, jersey barriers, parapet walls, those types of applications. There's a lot of unique work and a lot of unique applications to where the BEJS, because of the what that technology offers, that pre-compressed foam composite joint, it allows you to work with that in ways that other technologies, other materials otherwise wouldn't allow you to accomplish some of those transitions. Just some of the photos there. I really like the photo down there in the bottom right-hand corner because it really shows you, that extreme situation. You've got almost a 45-degree skew angle. You're coming in, you're turning into the parapet wall as a seamless transition, and then coming up and over that curb to seal it. Whereas, that's a pretty big nightmare for a lot of traditional materials. Here's some more photos, kind of sealing that jersey barrier parapet wall between the sister bridges there. We're not in that finger plate down there. Like I said, that's not the joints that we're trying to go out there and replace. with this technology. That's something that we're not going to touch. But like I said, you might even find something right there adjacent to it where BEJS or BOR is the ideal type of technology. Another look at some of those taper joints or, some of the spalling in irregular concrete. And like I said, not an uncommon sight when you get out there and see some of the conditions of these bridges and joints. They do take a beating. That is not an overstatement at all. We've got some resources online to help you guys try and size and make sure that the joints that are showing up on site are going to be sized appropriately. The three major metrics, that we look for. Got to commend Utah DOT and Becky. They do a great job of really capturing and putting this stuff on the drawings. You really need to know the joint opening. It's very important to know the temperature that you're measuring that so that you can adjust for the range in temperatures throughout the year when you're trying to go out there and install or sizing it appropriately. And then last but not least, the third metric you'd be looking for is what's feeding into that span. How much linear footage is actually going to affect and cause that joint to move. So we've been nominated and won some awards through AASHTO and ARTBA, as far back as 2014 when Irene was really pushing hard into this market, bringing this architectural product, this engineered product and applying it to the DOT market. And it really, like I said, it's made a lot of headwaves on the East Coast. We're an East Coast-based company, so that seems to be where the bulk of our success has been. But the more we're able to have those conversations, the more test joints that the Western states have been able to get out there and use. Our customer base out here is growing by the day. A couple more of those resources that I mentioned as far as getting some of the checklist or sizing charts, trying to make that available to engineers such as yourself. I think that ultimately, if we can size our joint, if we can get that information to size our joint properly, we know that we can guarantee a design that will work for you guys, that will keep a watertight joint, give you a 10 to 15 year life cycle on something like that. And at the end of the day, when it's cost effective like that, it does make it a great option, not just for retrofit, but for even stuff like new construction. We're going to be installing and doing a big project with Sound Transit on the new on one of the new 320. I believe the new 320 line that they're doing. It's either 320 or the 335 project that they've got going on there. But tons of brand new construction, all precast spans, a few poured spans. But they're going to be using the BJS on that new construction project as well. So not just a retrofit option. If you ever got any questions or if you need some resources, check out our website. Got a lot there. If we've got questions or anything, I'll open the floor to that. And
thanks. So owners like to put joints into a category. And I would guess most commonly we'll try and put your joint into the compression seal category. I just was wondering if you could comment on, does that fit, or do you need a new category?
Quite honestly, it's a great question because you're right. It comes down to, there's 13 states, in my Western territory, and they all want to call it something different, right? Personally, I would call it a pre-compressed foam composite joint. That would be the verbiage that I would personally use to describe it. I think that ultimately, write a spec that's going to work for your state and the customers that you're working with too. If they're comfortable with the verbiage of a compression seal, I think that the way that Utah DOT wrote their spec is that they've got a compression seal type A and a compression seal type B. So they've kind of created that even separation amongst that one main category to have kind of a couple subcategories there. From a nomenclature standpoint, I would call it a pre-compressed composite joint, pre-compressed foam composite joint. If that requires a DOT to create a new category for, as far as from their QPL list, some DOTs are more open to trying that out or putting in the manpower and the work. That's work, right? It's not easy to just snap your fingers and create a new QPL list. So if DOTs are willing and able and they've got the resources to work with us on that, then by all means, we'll try and take it out as far as we can. But sometimes, if the path of least resistance is creating a type B product on an existing specification, then I think that there's a way that you can write a specification or describe this material to fit it into a category if you have to. I think maybe one of the biggest differentiations on that would come, beyond the nomenclature, but really it comes down to like a lot of the testing and requirements. Something that might be applicable to a neoprene gland or something like that just simply isn't relevant to an open cell foam product. So, your testing, that might be a little bit, difficult there. That might be your biggest challenge of trying to lump it into something, but it still may be the path of least resistance. So, there's certainly states that have approached it that way, and they've done it with success.
Nathan, I think you said a 10 to 15 year design life we
Yeah.
should expect, right?
Mm-hmm.
And then at that point, kind of a multi-part question then, I guess. What sort of failure modes should we expect to see, at the end of that design life?
Yeah.
And then could you also speak to just compacted gravels and sands
Yep.
and durability to that under impact loads?
So, and I'll answer your second question first. Any type of debris, compaction of that type of stuff, sand, gravel, common stuff that's finding its ways onto bridges. We handle that very well. The back pressure of the foam is what really creates that resiliency to resist debris or push through. The one item that would damage a joint like this would be an extreme point load. So, if you found, if a real sharp nail or something like that were to be almost driven directly into it, then yeah, you're going to puncture it and you're going to be able to get through the silicone and get through that foam as well. But as far as just typical debris, gravel, that type of stuff, the foam is and silicone as well is resilient enough to resist that and not allow it to, puncture it through. But those extreme point loads is where you would probably see your mode of failure and where you might actually need to go in there and replace a joint like that. I think that even, if we're not getting 10 to 15 years out of it, usually the mode of failure is probably the header before the joint has actually failed. All right, thank you guys.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.